Welcome everybody to the lecture Query Store for SQL Server 1922 from 0 to hero, lesson learned from the field. This is a practical guide how to use Query Store. There is another lecture which is named Intelligent Query Processor in SQL Server 22 from 0 to hero. So what I will do, I will rush on Query Store and then I will go to the new feature immediately, because this is the main issue of the lecture. So let's start. My name is David Itzik, I'm DBA. About myself, 3 degrees, BSc, MBA, ME, engineer and 2 second degrees, specialist over 24 years in SQL Server, Oracle Service, Postgres, MongoDB, Redis, etc., etc. Lecture all over the world. I was an Oracle IoT administrator in Israel, also one of the Hebrew Global Data from Israel. So this is all my lectures, only the 2 years in SQL Server, Oracle, MongoDB, etc., etc. Yesterday, I lectured in Power BI Portugal. More than 200 people was coming to the lecture. So this is the lecture in Portugal. This is again me. This is the lectures. Lecture yesterday. So let's start. I'm not a smart people, but I love to read books. So this is the books I used for my lecture. I read them and I test them. They are more updated than the video, especially from Apress. So this is the source to the lecture, including Bob Ward. So sample database for this demo is World Importer and Adventure Work. You can download and restore them to SQL Server. You can create your preview. You can download SQL Server 20 Developer Edition. You should install SSMS. Starting was version 1.8.7. If you install SSMS, it's not only install Azure Data Studio. I have installed the latest version, which is 19.0.1. You can see it here, and immediately install Azure Data Studio. The features, release note of SSMS is that it supports contain always on availability group, support for SQL Server 22. Therefore, it's important to you to install the latest version of SSMS, which include Azure Data Studio. So what should I use as DBA ADS SSMS? Answer is SSMS. Why? SSMS is for the DBA. By the way, you can install in 2 minutes SQL Server 22 on Linux image container. This is the command. You can see it here. I don't have time, so I don't pass it, but this is the magics. Docker run and run an image of SQL Server 22 on your desktop without any installations. So this is how you install it on container, and then test all what you have here, and then copy the back file using Docker CP to the container of what the importer, change the owner to root, and then start to play without and installing SQL Server on your computer. You can also use Azure SQL Database free account, or you can use MS SQL 22 virtual machine in Azure. So now what we'll do, we'll pass very fast on Query Store and then go to the new features, because the lecture is the new features. So what is Query Store? Query Store is from edition 21.0.1.6 and Azure SQL DB. It's database level features. Query Store data is stored in database. User database, it's like a flag recorder because it captures all the queries, the query plan, random statistic, weight statistic, performance, execution plan, history. It's technology which is taken for Azure and for on-premise SQL Server. You can force for regress query your query plan. We see it. You can find performance regressions. You can establish a baseline and then troubleshoot performance. From SQL Server 1.7, there is also auto-plan correction and aggregation of weight statistics. Yeah, you have built-in report in SSMS for catalog view. So what information is stored in Query Store? Queries, query plan, and query task. Okay. So stored at first execution, that query store means that the capture policy. You have some capture policy to capture the queries. It's also store statistic, duration, read, write, CPU, etc. Query store aggregate this information. The default is 1 hour. At specified period, default is quarter an hour, 15 minutes. Data is persisted to disk into catalog view, and then aggregate and store per, and then it's aggregated and stored per interval of 1 hour. Stored by execution type, regular, abort, and exception. So you see, we have queries, query test, and query plan, runtime statistic, and wait statistics. Query store does not have any information about who execute the query, no login name. Query plans, it does not contain any runtime information, no actual number of rows or actual number of batches. Query store does not have information about individual queries. It's only aggregate informations, only aggregations. If you want to do it for individual query execution plan, you should use extended event or profiler. So I don't want to pass on the previous method, but you can use profiler server instead of. In the past, you could use profiler and for server side, but the problem is that you have performance heat and you have a stress file which grow and grow and grow and can blow your disk. So this is the old method. And then you have to aggregate and look for the events. And you have another method, I want to pass on about them. Okay. So, and you can also have DMV. You can also troubleshoot queries in SQL Server in DMV, but the DMV data is not persisted. You can use also wait statistic DMV, but again, it's not persisted. If SQL Server restart, all the data is lost. You have extended event, but in extended event, the data is not aggregated. Event sessions are not running all the time. You have to shoot it. And so all the new methods of troubleshoot SQL Server, including are very, very tedious and very hard to work with. So query store is game changer. Why it's game changer? Because it's, if you look at query store, there is asynchronous process which capture the query and execute plan to the temporary storage in the memory. On regular basis, yeah, query store in memory are on regular basis, query store stored in memory is written to the database. You can see it in asynchronous. There is minimum latency of query store, data collection and query optimizer. There is one exception. We'll see it. If you have query force, you want to deploy a force, the plan guide force will be used instead of the plan generated by query estimator. So again, this is execution plan. We have asynchronous data collection in memory, and on interval time, this data is written per database to the disk and persisted disk in query store. You can see it here. So our query store collect the data. There is this plus store, the compilation execution. So you can see there is process of query store in memory. There are async data collection of plain store, runtime store, wait and store, and there is async write to the query store catalog per DB. You can see it here. It's per DB. Okay. So information. So you can see that you can information like query execution time and wait experience during the memory is written to the memory. Data is aggregated. If you go to SMS, the default, you can see that the default is 50 minutes in the memory. When written to the disk, it re-aggregated based on the collection. So the default of the interval is 60 minutes. You can see it here. Aggregation gives you the ability to compare to different time and period with baseline. So you can see that. You can see that the query store in read-write state, and you can see all the options here. So if you have cross database query using three database name database, a table, etc. So the query also will be recorded regardless of where the database is being retrieved. So because all the data collection done in query store get written to this asynchrony, it is possible that there is a loss of data. Why? Because the data The data may be so there is data and flash to disk. Many you can flash the query store in memory using this query store flash DB. Query store catalog is view in DB backup, also in DDB, as is also including the backup, so you can move it to another support. It's part of the DB clone database. DB clone database adventure clone. You can see it here. Also, the query store statistic is being cloned, and you can move it to the support, or to other test environment. So query store capture mode is auto. Auto, it means capture all the relevant query based on the execution count and resource consumption. The default starting with SQL Server 19. The algorithm of how you capture the query is not documented. There is the option of custom. Custom is a new option to help you with controlling what data was captured, and it's good for other query which can blow the query store. So SSMS has 737-bit report. So everyone can use the report, not also the DBA, also the developer. The only permission you need is to be DB owner of database. So you can see the query store here. So if you go here, there is a request query report. Which query which will perform better earlier now, and now it's performed back. You can see if you click here, you can see the query and the plan ID with the different execution plan. Why plans are regressed? You can see it here because the change statistic data reliability index have been created, altered, or deleted. So you can see that there is request query. Each bar on the left represents different query. If you click here, you can see the details here. It can be part of stop procedure, trigger user-defined function, or other query. No, part of. The default period, if you go here, is last hour. So this is the for example, if you click here, you can see the report for the last 1 hour. This is the bar per query. If you click here, you can see the query. If you on the right side, you can see the query which are regressed. So this is about regress query reports. I passed fast because I want to go to new features. Our regress query, what is the criteria for regress query? This is the condition. The condition is where CPU time regress where CPU time regress percent per is greater than 0. So regress percentage is calculated as follow: max CPU time minus east max CPU time divided by east max CPU time, its percent. So this is the only criteria for the query to be appear in the regress query report. So it means what is so this is how you calculate the regress criteria. So we have 4 regress queries criteria, which is CPU time. So it can be higher than duration if the query run in parallel. For example, if you have 4 calls for 1 second, duration is 1 second, but the CPU time is 4 seconds. You can see it here. Logical reads in kilobytes for memory of SQL buffer pool for the query, always 8 kilobyte page. Logical write to the buffer pool. It's always 8 kilobyte page. Physical read in millicolite, a read from the disk when query need to be on pages. Physical reads is high sign of memory pressure. So you can see it here. Memory consumptions. Hash table and sort. It's about hash table and sort, row count in the memory bed. Mass function, it's average duration that will be high extreme value. So you can see it here. There is the criteria. So if you look here, you can see all the request queries. You can see all the request queries here and the criteria in last hour. You can see it here. You can see it here. If you over one of the bars, you can see the query. You can also compare between query if you between plan of the same query. So if you choose here 2 plan, you can compare between them. You can see what is equal and what is not equal. There is another report which is overall resource consumption reports. This is very important report because it shows the resource database is consuming by default for the last months. So the default show 4 categories of performance. It's duration in milliseconds, execution count, CPU time in milliseconds, and logical root. So this is it's very, very important because you see where the system was in spike. So you show the resource database that is consuming the default for the last months. Very essentially, you have reason scratch. So determine what a normal workload, you can determine what is normal workload for your database. Collection data is interval length minutes. Data can be aggregated in 1, 5, 10, 1, 5, 6, and 1, 4, 4 minutes interval. By default, there are 4 categories: performance, total amounts, duration, execution, CPU time, and logical rate. So this is very pretty report which will show you where your system is high peak. So this is, and you can see the query which go the overall consumption reports. There is, you can see here a query which show you the top queries by duration in the last 2 days using the catalog view. So this you have also the resource consumption report, which where can you see the high resource top resource consumption queries. If you click here, you can see the query, and then the query with high resource consumptions. The top resource consumption query is the most important users report. Why? Because the developer can go to this report and select this the query, and downstairs you can see the query and the recommendation for the query. Okay, here we can see that there is a missing index. So there is 25 criteria for metric for the top resource queries. You can see them. You can change the aggregate statistic to average, max, mean, standard, and total. So you can see it here. There is also query weight statistic report. It's very important because it shows all the total weight statistic by category. You can see it here. Query stock tell all the weight statistic and group them into 23 categories. You have hundreds of weight events, but group them into 23 categories. The default by total, you can see it here. So query statistic report categories, so you can see the weight statistics and the queries. There is also tech query report if you want to track some query. And you have also force plan. Force plan if you want to force specific plan. There is a report of high variation report if the query taking high resource at one point and low resource at other point. So you can see it here very clearly. Note that there is shape. Circle is mean that the query completed. Square means that the query was cancelled. Triangle means that the query was aborted. Okay. You can see it here. So this is the meaning of the shape. If you run this query, you, for example, list all the query that time out or finished because of an error. You can see it here. This is a list. This is the query which lists the most expensive query by CPU time in your production used per database. You can see it here. So this was a quick introduction to query store. Now I want to pass to the new features. I'm assuming that you know something about query store. And now I'll talk about the new features because I don't have too much time. So this is the most interesting things. So let's talk about what we saw now is query store. Query store you can use SQL Server Management Studio in order to see all that and to shoot and trouble all the queries. So let's talk about the intelligent query processor in SQL Server 22. So from SQL Server 1.7 to SQL Server 22, there is IQP, Intelligent Query Processor. I will talk about the next generation from SQL Server 22. This is a family of features which improve the performance of existing workload because you don't have to change the application or to do a minimal effort for tuning. But in SQL Server 22, some of the new features require query store. Therefore, I will focus on this feature that needs query store to be enabled to persist information of the queries in a plan. Each feature can be disabled in case of performance regressions. It can be on the DB level by changing the compatibility level, or at the query level by using a hint. So if you look here, RDMS scalability performance, addition and support feature of SQL 22, you can see that automatic tuning is feature of only Enterprise Edition, batch mode as David shown Enterprise, batch mode memory grant feedback Enterprise, interval execution plan, it's Enterprise. So this, you can see all the features, but these features specifically are for Enterprise Edition. Other features are included in Standard Edition. So let's talk about memory grant feedback in SQL Server 22. Why I'm talking about memory grant feedback? Because memory grant feedback use query store in SQL Server 22. So the demo script is memory grant feedback in SQL Server 22 demo, demo David by David Itzik. So what is memory grant? Memory is required to store the rows to be sorted by the sort operator. If you sort, you need the memory. A hash join requires two inputs, the build input and the probe input. Only build input required in memory. Why? It takes the smaller table and put it in the memory. Therefore, hash join, and this is the build table. Therefore, hash join need a memory. Very rare. Sometimes we need memory for parallel plan with multiple range scan. So we need to find the right size for the memory grant that will be estimated for the query estimator. How do we do it? So if we have incorrect estimation, there is a performance problem. Why? Because if we do underestimated, the query does not have enough memory and need to use the disk space to or temp DB. It's like swap the file. So there is expensive spill to disk. So why it's not good? Because it uses tempdb as paging file, and tempdb is not fast as the RAM. Overestimating if the query took some memory, so other memory that need memory, other query that wait until the memory is released, especially if multiple query needs a memory grant. So the symptom that the wait up is resource semaphore. That if we have too much demand of memory of other query, the symptom is resource semaphore. So underestimated, overestimated. Memory grant feedback. So memory grant feedback in SQL Server evaluate how memory was actually used to compare with the initial memory grant and the start of the execution. So on the next execution, if the memory is higher than initial grant, memory grant is increased. If memory is lower, it's decreased. So it helps us to adjust the memory grant size for both batch and raw mode operator. So SQL Server 1.7 use MGF or memory grant feedback for batch mode operation only a column store compatibility 140. SQL Server 19 use MGF for raw mode operation, the compatibility 150. But batch mode on SQL Server 1.9 can be used without column store. But in SQL Server 22, we add the persistent and percentile. This is the enhancement to use memory grant feedback in SQL Server 22, and it's also good when you use compatibility 140 or greater. So what is persistence? What is persistence? Persistence, you store the query plan inside the query cache. So, but plan in the query cache can be evicted. Why? Because if you restart SQL Server or do a failover to available group, the query plan will disappear. If you use in the statement the option of recompile, we will create a new plan and the plan will not catch. All the feedback which is lost and memory grant feedback have to start again. So it will impact the performance of the first execution. So if in case we have, so this is one, volatility, disable MGF if we have constantly having to adjust the memory grant, like here, you can see it here. You can see it here. You can see it here. The memory is for the same curve at time. So we have to disable MGF. For example, we will see it if we have parameter sniffing problem, PSP. So memory grant feedback will disable itself if the memory consumption is not stable, is going like this. So how do you see it? If memory grant feedback attribute in the query plane will be with ID, feedback is disabled. Or there is extended event, memory grant feedback will disable extended. But this condition is migrated with the persistent and persil for mode memory grant feedback in SQL Server 22, and we'll see it now. So what is the improvement in SQL Server 22 in memory grant feedback? Persisting the memory grants has information along with other query information in the query store. In the query store, store all the memory consumptions. So all the history. So even the plane is evicted from the memory, it's still there, the memory consumptions. So grant information will survive across cache, eviction, and server restart. Memory grant adjustment are based on the recent history execution and not on the most recent use grant. So if we want to do the memory grant adjustment, we can use the history in query store. So SQL Server check the entire history of memory grant and we consider that 90% of it. So what is 0.9%? 0.9% is the point at which 0.9% of the given population fall below it. In other words, it cut off for being the top 20% of any given group. Memory grant, know that memory grant in SQL Server 22 can waste memory in case when only a small amount of memory is needed. To improve velocity problem, memory grant feedback can also use a percent-based approach instead of disable the memory grant feedback in SQL Server 1.9. Rather than using the previous used memory from query execution, we consider the history of previous memory used to adjust the memory grant in applicable across many query execution because it's in query store. This approach avoids split. So if we use this approach for memory grant, is memory grant adjusted attribute in the query plane with a value of yes percent adjustment. If this attribute in memory grant is yes percent adjustment, it means it's taking the information from the history in query store. This is the default for SQL 72 or compatibility 140 or greater. To disable this feature, if you want to disable it, we only say memory grant feedback percent to off. So very fast, this is the commentations. And now we'll see a demo. If you want to disable batch mode memory grant feedback without changing compatibility level, so memory grant feedback can be disabled in database or statement. At SQL Server 1.7, it's very confusing. Alter database scope configuration set disable batch mode, memory grant feedback on, disabled. In SQL Server 19, it's other syntax. Alter database scope configuration set batch mode, memory grant feedback off. To re-enable, in SQL Server 1.7, alter database scope configuration set disable batch mode memory grant feedback off. It's off because it's disabled. In Azure SQL DB, SQL Server 1.9 and higher, alter database scope configuration set batch mode memory grant feedback on. You can also disable batch mode grant February for a specific query. How? You write the query and here you use the hint disable batch mode memory grant feedback. So raw mode grant feedback. It's starting for SQL Server 19. It adjusts the memory grant size for both batch and raw memory operator. You can see it here. So how do you know it adjusts? Because there in the execution plan you will see is memory grant feedback adjusts and last request memory, which we added to the memory grant info. We'll see it and current XML plan. So the last request memory show the granted memory in kilobyte from the prior execution. These memory grant feedback adjusted show to check the state of memory grant. This is the passable value. We'll see it now in demo. How to disable or enable memory grant feedback? For disable raw mode memory grant feedback, alter database scope configuration set raw mode grant feedback off. To enable, alter database scope configuration set raw mode grant feedback on. Disable raw mode grant feedback as use hint. You can see it here. You simply write this hint. A persistent mode memory grant feedback. This was introduced as SQL Server 22 as improvement. So How do you disable it? Alter database scope configuration set memory grant feedback percent off. The default for memory, this is how you disable it. Disable persistence. Alter database scope configuration set memory grant feedback persistent off. If you disable memory grant feedback, it will also remove existing correlated feedback. So the default setting for memory grant feedback is on. So let's see the demo. So this is the demo here. This is the demo here. You can try and use the script yourself. But what I'm doing in the demo, first, I will create a table. This is create a demo table in worldwide importer. You can see sell all details. Then I populate the tables. I populate the tables with two rows. So here is the CTE, and then I insert two rows. You can see it here. Select top two from order where product ID 115. And then I populate with another rows. So for product ID 115, you can see it here, two rows. And I populate with 20K rows with product ID 104. You can see it here. Insert cell order, select from order D where order D product is 104. And then I create the test procedure. This test procedure will do select on the database by using the product ID, PID parameter. So if we go here and run this, you can see it here. Insert two rows and then insert and then create a procedure. Only this. You can see it here. This is executions. Run. After I do it, I go and enable. First, I will set the compatibility to 160, which is the SQL Server 22. Other database world import set the compatibility level 160. Then I will clear the query store. I will enable query store and clear it. Why I should clear the query store? Because memory frame grant feedback need query store. Other database world import set query store operation mode read write query capture mode all mean capture all the queries. Other database world imported clear all, and they enable all SQL Server 17199 IQP feature, including memory grant feedback persistent grant on and memory grant feedback persistent on. You can see it here. And then I check using select star from sys database scope configuration. So if I go here, see it here. You can see it here and here. I run it. And you can see that this is the database scope configurations, and especially memory grant feedback persistent and memory grant persistence will on. And select from sys database scope configuration. Then I clear the buffer per database. DDBC preparation, this is for clean buffer. Now let's run this query. This query only two rows. Exec USP get order. This is PID 110. You can see 115. Sorry, you can see it here. And if you go to the execution plan properties here, you can see it here, and you can see that memory grant info. You can see that is memory grant feedback adjust? No, because it's first executions. The desired memory is 1415. Granted memory is 1024. So if you go here, you can see that I run start with product to return to row, and you can see the result here. Now I run again and run again. Now I run again. The procedure which return only two rows. And if I go here, you see properties, you can see. Is memory grant feedback adjusted? No, it's accurate grant. So this is granted memory. So you can see it here. So if we look here, so why it's accurate grant? Because if there is no spill to disk and the statement use at least 50% of the granted memory, and it used at least 50% of granted memory, you can see far. So the memory grant feedback is not triggered. So this is no accurate grant. You can see it here, it's accurate grant. But let's go crazy and return thousands of rows. So execUSP get all the detail, PID 104. This is return thousands of rows. So see what's happened. So if I go here and return thousands of rows, you can see it here. Look, there is here yellow sign. Go to properties, and if I go here to the warning, you can see the warning here. And we have this message. So what this message said, okay, the current memory grant will be not enough to run this query as expected. We get a warning on the sort operator. Operator use 10 dB. The yellow sign is means use 10 dB to split the data during execution with split level 1 and split spread. So data from memory will download from memory to the 10 dB. Sort route, you can see it here, 315 pages and read pages from 10 dB. And if you go to the XML plan, you will have a warning like this. You can see the warning like this. So this is from the SMS properties, and this is the XML. Now we'll run again the queries 1,000 rows. Let's go here, run it again. You can see it here. And there is no sign here. And if you can see here, so desired memory, this is the memory, and you can see is memory grant feedback adjusted? Yes, adjusting. Yeah. Is memory grant feedback adjusting means that the feedback has been applied. You can see there is a feedback before, and there is a feedback applied from the previous execution to adjust the memory grant. This is memory grant. No 10 dB spills, no yellow sign, result in a significantly faster execution time. So if we go here, you can see it here. And you can believe me that memory grant info, yes, adjusting. Okay, now let's run again the query with all the 2 rows. So we'll now have excessive grant. Why excessive grant? Because the memory grant detective excessive grant, which may impact the availability of the, because previously we granted this memory, but now we have only 2 rows. So we don't need too much memory. So we have here yellow sign. So if you go here and run here, you can see it here. You can hear the yellow sign. If you go here to properties, okay, and you go here, you can see the yellow sign, the column, and you see the warning. You can see the warning. So now let's create a new demo, which run and check the value of if memory grant adjustment. So if you go here, now what we do, we'll clear our memory. You can see per database, DBC4 can be claimed buffer. And now we'll run as follow. I don't pass all each run, but first run 2 rows, which return only 2 rows. Then I run 104, which return 1,000 rows 3 times. Then I run again 2 rows 3 times. The step 115 return only 2 rows. And let's see what happened. Okay, so if you run this and you look at the properties of the SSMS, or you look at the XML, you see that run the following execute. For the 2 rows, you will see, is memory and feedback adjusted for the first time? No, first execution. Then the second running, no accurate again. Now for 104, which return 1,000 rows. For the first execution, no accurate again. 4, yes, adjusting. 5, yes, table. If I run again 115, 2 rows, is memory yes is stable? Yes, you can see that now it uses query store. Percentile adjusted. Now you're going to query store to adjust the memory. Is memory reference adjusted? Yes, percentile adjusted in the 3. So what's happened here? We run 2 times the procedure which return 2 rows. Then we run 3 times the procedure which run 1,000 rows. Then again, we run the procedure which return 3 times, which return 2 rows. So you can see that the memory, the consumption memory has peaks from high to low. So how is the memory adjusting? The memory adjusting using this mechanism of query store, which reside in the query store. You can see. So you can see what I show you here. This is the multiple execution 1. This is the second. This is 3 and the 4. And there is a feedback. There is a feedback. How do we see that there is a feedback? If we go here, if we run here, if you run this query, you can see that we have a feedback valid. The feedback is stored in the query store. And what we see in the feedback, last memory kilobyte. So what we see in the feedback, let's see. Why there is feedback? Because, again, you can see that the memory is not going with high value to low value. You can see, granted memory, you can see that the memory is going up and then decrease slowly and slowly because it's using percentile adjustings. Okay. And if you run this query in plain feedback, you can see the query plain, have this result. Feature description means that memory grant feedback was enabled. You can see it here. You can see it here. Feedback, memory grant feedback and feedback. And you can see it here. And it means that this used the query store. So this is how the mechanism of memory grant feedback was used. In this way, you can see that when you use percentile adjusting, we don't have peaks like this. This is the actual needed. This is lattice grant. The memory is going from peak and go slowly down because it used the percentile mechanisms. You can see with the blue, this is from Microsoft documentation. You can see it also here. The granted memory is going down slowly. There is no peaks. Okay, so this is a percent-based calculation of a rest register or query. Okay. So adaptive join does not use. And let's talk about query store hints in SQL Server 22 and the parameter sniffing problems. So listen is very important material. So query store improvement in SQL 22 is by default enabled for new database only. So SQL Server never need to change the default DB when. So if you restore the database, you have to change the default DB. If you restore database, If you restore the database, this is the default, but if you store for lower version, you have to enable query store. So why now query store is enabled by default in SQL Server 22? It was not in SQL Server 1.19. Why? Because there is no more scalability improvement. In previous versions, there was a problem with queries which blow the query store. So now it was improved, especially for the ad hoc queries. Ad hoc queries act like dynamic SQL, which change all the time. So there is improvement for ad hoc queries, limit due to internal memory limits and throwing in query store. There is also custom capture. Remember that there is custom type, custom in query store, that you can change the policy of capture, which queries you want to capture. So you can do a fine tuning. There is better default starting with SQL 32 and Azure. So again, in SQL 32, query store is by default. So why should you use QueryInt today? QueryInt helps to provide solution to various performance-related issues. Query hints are using the options clause, but you have to change the code. But there are times that you cannot change the code with QueryInt. Why? Because sometimes SQL is coded into the application, like entity framework, Hibernate, etc., etc. Sometimes TSQL automatically generated by application like entity framework. So in previous version, you have to rely on a play guide, but they are very complex to use and to manage. So here is what is parameter sniffing? At time T1, we are passing store procedure with parameter X. Performance is tremendous, but at time T2, we are passing parameter and now performance is bad. This is parameter sniffing. Why? Because plan created from one value perform well. Plan that created for one value perform well for the query immediately called, but however, all other queries perform very poorly with the same execution plan. So the goal is to get optimal performance from query at all the time with all the parameters. So how did we resolve? Notice this example: parameter sniffing with query store in SQL Server 1.6 and 1.9. So this is what the technique. We should run TSQL code against the data collected in query store, and then use the regressed query store report. We'll see it now, and then compare the execution plan in time T1 and time T2. So we can see it here. So we run query store and compare the execution, and then we plan the least worst plan. You can see it here. This is the better plan. This is the better plan. Once we decided which of the plan we wish to force, click on the plan ID, you can see it, click, and force it. But this is a trade-off. So query store int, it's not preview, it's my mistake. In SQL 32, it extended dependent query store. Query store by default in Azure SQL DB and SQL 22. So example where query store int can help. You can compile the query on each execution, so you have a better plan. You can cap the memory against size for back insert operation. You can limit the maximum degree of parallelism for statistic updates. You can use the Azure instead of nested load. You can use compatibility level 110 for a specific query while keeping everything else at compatibility, which is higher, 150 and 156. You can disable row, goals, and delete for select top queries. So if you look here at the documentation, it will show you the cases. But query store will support the statement query. It's level in the first version. Query store are persisted and survival will start, because if the SQL Server restart, query store will still persist. Why? Query store int will still persist. Why? Because it's stored in the query store. In query store when you want to force the plan. So the override hard code is meta level hint and plan guide hint. Okay. If there is contradict what is possible, it will not block any query execution, and query int will not apply. So how do you use query store in SQL Server 22? First, you have to identify the query store, the query ID of the query statement you wish to modify. How do you do it? Very easy, with query store catalog view, SMS built query store report, or Azure portal query performance. So once you identify the ID, execute SP query store sets int with the query ID and the query int you wish to apply to the query. The string of the query can contain any one or more hint. In case where the int would cause the query to fail, int is ignored, and the last fail or detail can be viewed in the sys query store int. So Let's see it. To create or update int, use sp query store send int. Int are specified with the options. If no query store exists, there will be a new query int. If QSN already exists, so the last value will be over the previous value. If query ID doesn't exist, and there will be raised. To remove the int, we have sp store clear store int. If you look at execution plan, you will have this. Query store statement int text, actual store query store int, query store statement int ID, unique identifier for query int, query store int store, this is store query store. So let's see example more clear. So this is demo script, query store int in SQL Server 22 demo by David Itzik. So first we store while word import, and then we enable query store on the database and clear the query store, the database query store clear, and then capture all the query capture mode all. You can see it here. So select actual state desk from C database query store. It's mean read write. So query store is clear and read write mode options. Very, 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 very simple. Now we create our store procedure for the demo. Create or alter. This is the good syntax. Create or alter. It will not drop it. Alter. USP get order ID. It get account person ID as integer, and then select customer ID blah 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 from cells in advance where account person ID is equal to the account person ID which was as a parameter. First, so if we look at the table, you can see that if you count the total account person ID group by account person ID that we have, you can see that there is high skew. For account person ID 3260, there are only 2 accounts. You can see select account person ID, total account person ID from sales innovice where account person ID in 2013950. You can see that for account person for 3159, only 2. For account person ID 2001, 22160. So there's a big skew in account person ID. So if we use this select is range key I key, is crucial from C start across apply DMC Instagram object start ID as is, where know that we have non-cluster index, which is named FK cell innovice account person ID. This non-cluster index in the this on account person ID is non-cluster index. So if you query this on the statistic, you see also that there is a big skew. You can see the account person ID equal row, and 2160, 2150, 1 row again. So let's start play with our in demo. First, we will remove plan from the cache. Alter database scope regression clear, procedure cache. Set statistic IO timer on. Now, set statistic IO timer go. Now I run exec USP get start ID 39533259. It will return small result, 8 rows. For small result, it will do nested loop. You can see this is the execution plan. There is a nested loop and index 6 on the non-cluster index. Because it's non-cluster index, then we have look up to the cluster index. So again, we have index 6 on this 8 rows. But the memory is the execution plan is memory. The execution plan is index 6 and it's memory because it's a plan cache. If and you can see that there is very small logical reads. But if I run the second call to procedure with 2110, which will show 22,000 of rows, you can see that it will use the index 6, which is used before. And now the logical read will be very high. 6530 logical read. Why? Because to return a lot of rows, instead of using table scan, it will use indexing on our cluster index. And the price is very high. So let's go crazy and now remove the plan from the cache. Other than scope configuration clear procedure cache, statistic IO, And now run the first result. Exec USP get order ID 21101. How? Now we'll have cluster index scan. Why? Because this is a lot of rows. Instead of doing index seek on the non-cluster index, you'll go directly to the table and we'll scan all the rows. And now the logical reads is very low. Then the index seek. 5,000, 7,000, about 8,000. And you can compare it to it. But the plan is the cache. So if you now run the small result, which not only 8 rows, exec USP get order 3959, you can see it here. It will do a cluster index scan for only small result of rows. And the logical reads for small rows will be higher. You can see it here. So if you go, you examine the plan execution plan, you can see it here, go to select, you can see that the parameter value is 2110 because this is the first, the plan was first executed with this parameter 20111, but the parameter runtime in the for the small rows is 32509. You can see it here. And how do we handle it? You can use the with recompile, which means recompile the plan. So if you run the big result set, exec USP get order ID 2110 with recompile, the query will be recompiled and we have cluster index scan. If you run the small result set with recompile, 8 rows, you will have index seek. You can see it here. So it's good, but how do you can do it without any changing the code? So this is the magics. Query store ints. So first, you can verify that query store ints in query store core ints. You check if there is already existing. So select query int ID, query int text, last query fellow reason, last query int fellow desk, query int fellow count, source that from query store query hint. So there is no query ID. Now I want with the query store int, this is the 2 steps. First, you find the query ID. Now I have to find the ID of the query, which I want to do a query int ID. So how do I do it? Select query SQL test query ID from sys query store query text. Inner join query store query on query text ID, where SQL query test lacks order by count person ID. So you can see I've joined 2 tables in the system catalog of query store in the table in the database to find the query ID of this, not the plan ID, the query ID of this query. So this is the query ID. Now it's very simple. Exec SP query store 13. This is query ID 1 and value, and this is the value of the hint option with compile. You write it like this. Now I should verify that is in query store query int. Say query int ID, query int text, blah 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 blah, query store from sys query store int. You can see that I have query int ID 1, query ID, and this is the query. So let's see if the magic is work. Add a database configuration, set clear procedure cache, and when I run the 2 queries, you can see that for the big result, I have cluster index scan, and for the small result, I have index seek. And I haven't changed the code, nothing, because it's in the query store. Now, now I can change the query. For example, I want to change the query to max ODP1, parallel 1. So exec SP query store ND, query ID 1, and value option max ODP. So again, other database code configuration clear procedure cache would clear the procedure cache. The same query show you that I have now query int ID 2 for the query ID, and now it's option max ODP 1. So if I run both query and go to the select properties, you can see that non-parallel reason is max ODP set to 1. You can see it here. Why? Because this was the hint. Now I want to get crazy and to give 2 hints. So recompile max ODP1. Again, XP query store set in query ID1. Value, recompile max ODP1. The same query again, and now query ID jump from 2 to 3. Query int ID 3. Query ID 1, and this is the query in text. Option recompile. And again, if we check, we see that is max DOP set to 1. And if you go to execution plan XML attribute, you can see that there is query store statement in text, query store statement in ID, and query store text and its source. You will see that query store in ID is 3, query store source, this is the text, and query store in source, the user. So this is the execution plan. Now I want to remove it because I don't want it anymore. So exec sp query store clear in query ID 1. So if I run this will clear the query test. But in SQL Server 22 tell us there is parameter self-sensitive clean optimization. Please use it. You will automatically do it. You don't have to do nothing. So it addresses a scenario where a single cache plan for parameter query is not optimal for possible incoming parameter values. So how do you enable PSP optimization? You should enable completely 160 and query store is turned like this. Alter database, my database query store capture mode auto. And then if you enable PSP added the option hint to your query, option plan per value, object ID, one file forever. If you want to disable a DB level, alter database scope configuration set parameter sensitive plan optimization off. So parameter self-sensitive clean optimization can, it's told in the documentation, can solve this issue. But let's try if it's solved. So now use word1 importer, set statistic IO time on, alter database current set completely level 160, and it should solve it. Alter database current set query store on, alter database word1 importer set query store clear everything. Alter database current set query store capture all the queries. Now DBC3 Pro crack, and again you run the query exec USP get restore order ID 3259, and if you look here, it's only 2 rows, and I have indexing. But now, if I run the result with thousands of rows, exec USP 20011, again I have indexing because parameter sniffing parameter is not working. You can try it again and again and again. You see that for the big result, I will have index 6, small result I have index 6, and not like query store int where I can ensure that for the small result I have index 6, and for big result I have a cluster index scan. So if you look at the documentation, Brent's Other, which is a famous tale, but it's great, but it's only work for equity search, no thread search. One of the most common parameters sniffing problem is that the date range issue will be start and date parameter. PSP is not coded for direct equality search only. Whether you're looking at the plain cache or if you're using SP Active or your monitor tool or query store, this is Alec Darling demos, which is another Microsoft MVP. SQL Server can no longer tell where the query came from. So if you look at this demo, you can see it here. So, so you can see that PSP not all the time only work, and you have to use query store int. Disable only I bleed. This is something I found now. So there is optimized plan forces. If you read Bob Ward's the book, memory, SQL Server 22 revealed, sorry, So there is optimized. So if query store is enabled, so when the query store is compiled, there is a compilation script generated. If the compilation takes significant amount of time, okay. So if the queries take a lot of time, so the trash is not documented. What did happen? But you see that we can force a plan. But if the plan is very long and very complicated, then can be a compilation script. So the threshold is not a compilation. The compilation phase for the query execution is affected the overall durations. So how do we know what queries are eligible for plain forces? If you look at this link, you can see that query plans. How do you know that query can be forced? If we see the presence of statement opt level full, and if you do not use the user compile hint. Okay, so this is optimized plain force in store. Query store is eligible to be forced if it has this condition, statement level full property, and if you don't have the compile hint. And there is another optimization which call the optimized plain forces. So again, I have a demo, but I will not show you demo because if I will pass, time will pass. But assuming that we have a big join, alter use order importer, alter database scope, configuration clear procedure case, go set a specific time on go. So this is the okay, sorry. You can see it here, I already run it. So you can see that we have this. Okay. You can see that we have this join. You can see this long join. You can see it here. You can see this join. This is a very long join. Very long query, which take about 9 minutes. You can see it here. So if I run this, and look at the SSMS, I see that the parse time, you can see that if you look at the message, you can see that the message that the compile time and the compile time, it's 125 millisecond. Sorry, 1 times 56 milliseconds, and the overall, so 155, and the SQL Server execution CPU time is 2094 milliseconds. It's about 126 divided by 2094. Okay, so this is a big join. So first, so now we want to Bob said that it will be optimized in query store. First, you have to find the query in the query store and to find if it is candidate for optimize. How do you do it? Use word imported. Select query ID, plan ID, average compile time, duration as average compile time, last compile time, yes compile time, task query plan ID from sys query plan. You can see that, you can see the query ID and the plan ID, but you have here a new field which is named as compile replace script. You can see it here, 1. Now, if you look to the SSMS report, you can see the query here, plan ID, and you can see it here. Here. If you go to total consume requires, you can see it here. You can see the plan here. Okay, no matter because okay. So if you look here, you can see this is the plan ID. Now I want to do check if the the query is eligible for false, and if there will be optimization of compile replace script. So how do you do it? If you go use this query, select query ID plain ID average compile time duration divided by 110 as average compile time, last compile duration divided by 110 as last compile time, as compile replace script, you can see that we have here the query ID, the plain ID, the query ID and plain ID should not be the same. Average compile time is 145 and last compile time is 123. And as compile replace script is equal to 1 mean it can be this optimization and it can be also false. So if you look at the XML file or you go to the query properties, you can see that this query can be false because optimization level is full, and we can do a further compilation with script compilation. Query compilation is 1. You can see it here. You can see it here. You can see it here. So let's now force the query. How do you force the query? I'll show you. Exec SP query store force plan query. This is the query 5.7 and plan ID is 5.7. Again, plan ID query ID should not be the same because for the same query ID you can have several plan IDs, and I want to force a specific plan. Now I can verify that the query plan is false. Why? Because the value is false plan is 1. So select query ID, plan ID is false plan, average compile duration, average compile millisecond, blah, 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 blah. From this query store plan, you can see that is false plan, it's 1. As compile replace script is 1. Now, I want to see if there is significant reduction in compilation time. Why? Because you use these optimizations. This is internal optimization of Microsoft of the query plan. So the next time the query is compiled, we should see a significant reduction. This is what was said. Run the big join again. Be sure to run the entire script. It's forced to new compile. Observe the compile time with overall CPU time is better. So database scope conversion, click the procedure case, set to see time O. And now I don't see any change, any significant change, because you can see that CPU time is 105 and CPU time is 2047. I don't think if there is a great reduction in the compile time. This is after improvement, and this is before the improvement. Where is it? This is before the improvement. So I don't know. Maybe there is improvement because it's 125 divided by 2094. And here you can see that this is 15125 divided by 2040. So I have to check it more, but this is internal improvement in compilation time, but we have to check if there is a really reduction in compilation time.